Another application of these exponential models is going to be investments. So typically with an investment, you put some money into some kind of savings account or whatever you want to call it, and then you gain interest. And so, for example, if you gain 2% interest and you have $100, after the first year, you get $2. But then the second year, you get a little bit more than $2 because that $2 you got last year also gains interest. So it's not quite linear because every time you get a little bit more, and then eventually those little bits start to accumulate and become actually quite a bit. So, yeah, these are going to be basically exponential models. And here's our formula. We're going to have this basically A of t is going to be like the future amount or the value. And it's going to be given by this formula, P times 1 plus R over M to the Tm. So P is the present or the initial value of the investment. R is going to be the interest rate converted to a decimal number. And M is going to be how many times a year it gets compounded. So most of us have savings account where interest is actually compounded once every month. So that would be like M equals 12. So different types of investments have different accumulation marks. So you just have to read the question to see what you're going to set for M. So we'll go through the first two examples, which hopefully will kind of highlight here where this formula comes from, and then just do a longer term one where it's not really practical to calculate it by hand. So we're going to find the value of a $6,000 investment at 2.4% compounded quarterly after these 3 different time frames. And so getting started, we're going to find all of the letters here, but we are going to use that formula. A of t equals P times 1 plus R over M to the Tm. And so what we've got to do is we want to set up this formula. If we're going to plug in a bunch of different times later, we need to know everything but t in the formula. So we have to find P, we have to find R, and we need to find the m's. And there's 2 of the m's, they show up twice. So P is the initial investment. That's your $6,000. It's the primary value of whatever this account is worth. R is going to be the interest rate, but we need to convert it to a decimal. So we start with 2.4%, and then to convert to a decimal, we divide by 100 or move the decimal over twice. So it'll be 0.024. And M is how many times per year. So you have to be really careful about that phrasing. And in this case, it's quarterly. So M is going to be 4. Quarterly means 4 times a year. And so we have everything we need here for the formula. We should be able to put it together. My A of t is going to be 6,000 times 1 plus, my R was 0.024. Over M, which was 4. And then to the Tm, so T times 4. And then if I want, I can clean that up just a little bit because I can clean that decimal up. I'll usually try to give you decimals that are at least sort of nice. So we get 6,000, and on the inside there, I can clean that up. It should be 1.006 to the 4t. So that's going to be my, my general formula. And so just to see how this works, the first one will be 3 months. So I specifically chose that because that's actually 1 quarter, right? That's a quarter of a year. And so if we watch how this formula works, I'm going to plug my numbers in. So A of t maybe, yeah, so I'm going to just rewrite the whole formula, 6,000, 1.006 to the 4t. So 3 months is a quarter of a year. T should always be measured in years. So 3 months is actually going to be a quarter of a year. So we could write like a quarter or 0.25, whatever you prefer. It's not going to matter. But A of a quarter equals 6,000, 1.006 to the 4 times a quarter, which is 1. So we get actually just times 1.006, and we can calculate that. And it's $6,036. Okay, so just what this number means exactly is that we started with 6,000, and what we've got here is that after 3 months, we've gained $36 in interest. And $36 is a particular percentage of 6,000. It's actually a 0.6%. So basically what's happening is that 2.4% that's always presented as a total yearly rate, when they say that this is compounded quarterly, it doesn't mean that every quarter you get 2.4%. That would be insane. What it means is that they divide this 2.4 up into 4, and that's where the 0.6 is coming from. So that's 2.4 over 4. And so every 3 months you get 0.6 of interest. And ideally, like if it were linear, that would add up to 2.4 in total, but you actually end up with a little bit more because of the interest on interest. So that's sort of where this number is coming from. So this 1.006, what you're getting is the 1 is the initial 6,000 plus that 0.6% interest that's happening after the 3 months. And then this is telling you how many times that interest gets accumulated. So how many times do we need to keep accumulating these 0.006 growths? So that's sort of how the formula works. It's pretty similar to the doubling half-life formulas. It's all the same idea, but it does all come together. So, so 1 year, for example, if we do this one, what we're going to do is actually just plug in 1. Don't have to do too much thought for this. So this will be 6,000, 1.006 to the 4 times 1, which is to the 4. Make sure you do the calculation, the exponent before you multiply, otherwise your answer will look a little crazy. And so I get this number just a little bit bigger than 1, and I'm going to times it by 6,000, and we get approximately 6,145. And for this one, I'm going to round to the cents, so it'd be in 30 cents. All right, so in this case, what we're seeing, very similar. We have a total accumulated interest over a year of $145. Right, this is what we gained over the initial 6,000. And if we compare that to the original 6,000, it's a little bit more than 2.4%. So this is 2.422% of 6,000. So it's pretty close to the total interest you're supposed to get through the year, but when you break the compounds down into smaller amounts, it actually you get tiny little bits more, basically. So yeah, so we're doing this multiplier of 1.006, like we're getting 6,000 plus the 0.6%, and then we take that number and add 0.6% of that. And we do that 4 times. And that's what the calculation does for you. And then finally, the last one, 6 years, we just plug in 6. There's not going to be anything here that's any different. And what you'll see is 1.006, and we'll do 4 times 6. So that tells us we do this accumulation 24 times, 4 times a year for 6 years. And I'll work that out, 6,000 times 1.006 to the 24. And for this one, we're going to get 6,926.32. So after 6 years, you make almost $1,000, essentially. Yeah, so that is, yeah, these are the generic formulas for these compound interests. We could also solve for T. It's just going to be a bunch of rearranging of formulas. We could also even potentially solve for R. It's a little bit different, but we should be able to move things by just using equation solving techniques.